The process for a potato cannon projectile lab involves loading your potato cannon with said potato, filling the canister with hairspray, firing it. Once you've fired the potato, measure the time it takes for the potato to hit the ground, the angle at which the potato cannon was held, and the distance the potato travels. Okay, materials for this experiment include 1 can of hairspray, 1 rangefinder, 1 potato cannon, and a trusty spud.
Ready?
Yep. Impact. 3.82 seconds. The data found through the experiment, the length of the cannon, this measurement here through this measurement here, was 1.68 meters. The elevation of the cannon, so this measurement from the ground to the top of the cannon, was 1.12 meters, and then 6.8 meters, and that'll help us find our angle. And the distance traveled was 60.35 meters. The time was 3.82 meters, or seconds. Seconds. Okay. Using that, we can solve for the x velocity, which is velocity equals delta distance over delta time, which equals 60.35 meters over 3.82 meters, which is 15.8 meters per second, which will fill in here, 15.8 meters per second. This was 60.35 meters, and time was 3.82 seconds. Now we are solving for the angle at which the cannon was fired. So, which is this measurement here. We know that this is a right angle. The y value was 1.12 meters, and the hypotenuse was 1.68 meters. Knowing that, sine A over A equals sine B over B. Sine A is sine theta over 1.12 equaling sine of 90 over 1.68. That is rearranged for theta as theta equals sine -1 of sine 90 over 1.68 times 1.12. Theta then equals about 42 degrees, which can be added to our diagram, 42 degrees. Now we're solving for the maximum height of the potato. So when solving for the maximum height, we know the final velocity will equal 0 meters per second, and that it will be half the time, assuming that it goes level, which is what we are assuming. So the equation is delta D equals V2 delta T minus 1/2 A delta T squared. So subbing in our values, 0 times 1.91 minus 1/2 negative 9.8, 1.91 squared. Delta D is 17.88 meters. This value is this maximum height here, so 17.88 meters. So the initial velocity in the y-axis, so we're using the equation delta D equals V1 delta T plus 1/2 A delta T squared. And when we're solving for the initial and the final velocity, we know that the distance in the y-axis will be 0 because it starts and ends at the same point. So 0 equals V1 3.82 plus 1/2 negative 9.8, 3.82 squared. And that solves for V1 as 18.72 meters per second. And V1 will be equal to V2 because the displacement in the y-axis is 0. So 18.72, and no, that's not right there. This is just for the y, so this would be V1y. Which we'll write down here as V1y equals 18.72 meters per second. Now we are solving for the total initial and total final velocities, which will be equal to one another. So we know the x and y components are 15.8 meters per second and 18.72 meters per second. Knowing that, we can use Pythagorean theorem. So V total initial slash final will be the square root of 15.8 squared plus 18.72 squared, which the velocity is then 24.5 meters per second. So this is 24.5 meters per second, and this one, because it's going down, is negative 24.5 meters per second. From these calculations, we've been able to tell that the potato will leave the cannon with a velocity of 24.5 meters per second. It will reach a maximum of height of 17.88 meters per second, and it will hit the ground with a velocity of negative 24.5 meters per second. The negative is because it is moving downwards. During this time, which took 3.82 seconds, it will travel 60.35 meters with an x velocity of 15.8 meters per second. The x velocity is a constant because there's no gravity affecting it. Yeah, that is the flight of a potato from a potato cannon.